In this video, we're going to chain together two processes and look at how we can use tables of values to help us think about this. So let's consider the following context. Suppose you have a photo and you want to crop it to cut off 2 inches from the right-hand side and then resize it by scaling it by 1.5. Let's draw a little diagram of this. We've got a rectangular photo. We'll draw something like this. What we're going to do is cut 2 inches off the right-hand side. So we'll assume that this right here is the 2 inches we're cutting off. And we're cutting away this part right there. And then we have this new photo that's over here on the left-hand side. And after cropping off the 2 inches, we're going to take that new photo and we're going to scale it by 1.5, meaning that each side of the photo is now 1.5 times as large as it was before. So my drawing might not be to scale, but each one of these sides on the right-hand rectangle should be 1.5 times as large as the one over on the left-hand side. Okay, so let's assume that we have two tables of values relating these two processes, or representing each process. So on the left-hand side, we have a function f. We'll use a table to represent this function. And then function f takes the original photo length in inches as its input, and then outputs the cropped photo length in inches. We have some values for this. And then the function g will take as its input a cropped photo length in inches, and then output the resized photo length in inches, or the length of the photo after you scaled up by 1.5. Let's consider the scenario where the original length of the photo is 5 inches. So if the original length of the photo is 5 inches, then we see that value represented here as the input to this function f. And the table tells us that the corresponding output of the function f is 3, meaning that when we crop off 2 inches from the right-hand side, the cropped photo length is 3 inches. So after cropping, we have a length of 3 inches. And if we have a cropped photo length of 3 inches, we see that in our table of values for g over here. And then we can use this table and look at the corresponding output for this function g, which is 4.5, meaning that when the cropped photo length is 3 inches, the resized photo length is 4.5 inches. So in each one of these tables, we used the table to think about a process, and we actually ended up chaining together these two processes. So we took this process, and then we chained it on, putting this one at the end. Chaining together multiple processes is a very, very common thing in math and science. So this is a good idea to get comfortable with. Let's draw a little diagram to represent this way of thinking. So we can think of functions as kind of like machines that take an input, process that input, and then give you an output. So I'll draw a little diagram of a little function machine. It's not very pretty, but it'll work. We'll call this function machine f. So f takes in a original photo length, so original length in inches, and then f outputs the cropped length, so the length after cropping off 2 inches. Now the function g, so I'll draw another little machine for this function g. The function g takes a cropped photo length as its input. So when we get a cropped photo length out of f, we can actually end up inputting that into our function g, because the function g takes a cropped photo length as its input. And then the function g is going to output we'll call this the resized length, which is essentially the length of the photo after we scale it up by 1.5. So we have these two functions, and we can chain them together. Now in math, we can think about this as like two separate processes, or we can just imagine this as one single process. So we can take this entire thing and pretend like it's just one process. So kind of ignoring what happens on the inside, we know that it will take a original photo length as its input and then output a resized photo length. And we kind of just ignore what happens on the inside. So we could actually call this new function h, and h will take an original length as its input and then output a resized photo length. Going back to our table of values, we saw a function we had a table for our function f, and we had a table for our function g. We could actually use these two tables to construct a table for this function h. We'll have to chain together these two processes. So we did this once. We saw that when the original photo length is 5, the resized photo length is 4.5. So if we wanted to make a table for this function h, then we'd have two columns. One of them is the original photo length here, and the resized photo length over here. We know that if the original photo length is 5, then the resized photo length would be 4.5. And we can do this with actually multiple different values. In this way, we can use tables to help us reason about chaining together function processes.